Hi, today we're going to talk just about the parent functions. Those mean the basic functions for sine and cosine. So today we're just really going to look at just the simple part of it all. Okay, the x-axis is always your domain and the y-axis is your range. Again, this is your horizontal and your vertical. Okay, this will represent, the x-axis will represent the angle measurements. In other words, theta or x. The y-axis is going to represent the trig values at that angle. Okay, so the first thing we're going to do is we're going to look at the function of the sine of x. Remember back in Algebra 2, maybe your teachers told you you could replace f of x with y. We're just used to so many times using x and y. Okay, so let's use our unit circle. What is the sine value at y? Remember, sine is your y value. So at 0, sine is 0. At pi over 6, sine is 1/2. At pi over 4, square root 2 over 2. At pi over 3, square root 3 over 2. At half a pi, it's at 1. Then we're at square root 3 over 2, square root 2 over 2, 1/2, and 0. When we get to 7 pi over 6, we're at negative 1/2, negative square root 2 over 2, negative square root 3 over 2, negative 1, and our y values at 5 pi over 3 are square root 3 over 2, negative square root 2 over 2, negative 1/2, and back to 0. So all I'm using is the unit circle and looking for my y values. Now, the thing I would like you to do is also consider these decimals for now. So 1/2 obviously is 0.5. The square root 2 over 2 is equivalent to about 0.71. And the square root of 3 over 2 is equivalent to 0.87. Because now when we go down here and we graph, okay, graphing, we're going to go as high as 1 and as low as negative 1. And if you recall, we already kind of sketched this, but now we're going to really do it to the point. This is 0. If you think about the unit circle, the next corner of the unit circle is at 90 degrees, or pi over 2. Then we go to pi, 3 pi over 2, and we are back to 2 pi again. Now, if we really want to get an exact look at this graph, we also can break our unit circle down into fourths. So this would be pi over 4. Then we have 3 pi over 4, 5 pi over 4, 7 pi over 4. But as you know, on our unit circle, we also divided it up into thirds. And so we have pi over 6, and then we have pi over 3, and then we have 2 pi over 3, okay? So we've got all these thirds also along our graph. And the reason we want to do this today is we want to really look at where all these points come from. So now if I go graph my first point, at 0, I'm at 0. So this is the point 0, 0 on my graph. Then I have pi over 6, 1/2. Pi over 4 at square root 2 over 2, which is about 7.1, 8.7, and all the way up to 1. So we can see that curvature. When I come back down, I eventually end up at 0 again at pi. And now the negative values start forming. Again, there's my half, negative 0.71, negative 8.7, negative 1, and so on. So what we see is this really pretty curve, and that is the most important part of this whole thing. Now, what do we know about a circle? Is it continues on forever and ever and ever. And the sine wave also continues on forever and ever and ever. It'll just repeat itself. Okay? So we need to talk about some important terms here. First of all, when we talk about period in terms of our graphing, period has to do with the time that it takes to complete one cycle, meaning one time around the unit circle. The amplitude, you've heard that term before, hopefully. Amplitude has to do kind of with like the height of something. And then we've already talked about domain and range. So if you go back to this part down here, how long did it take to finish one complete cycle of the sine wave before it repeated again? It finished in 2 pi. So the period of our parent sine wave, this is our y equals sine of x graph, is 2 pi. The amplitude is the height of the graph when you cut it in half. So if I cut it in half, it's 1 pi this way and 1 this way. Remember, distance is not measured negatively. So the amplitude here is 1. The domain, well, the x values of the sine wave go on forever and ever and ever. They never stop. So they go from negative infinity to positive infinity. However, my range only goes as low as negative 1 and as high as positive 1. And you use brackets because brackets include that number, both negative 1 and positive 1. Okay, so we talked about domain and range already, but let's just make sure we have the correct definitions for them. Domain is your x values for which the function is defined. These are your inputs. The range is your y values or your outputs. The period, again, we talked about how long the function takes to repeat. The amplitude is the height of the function. And remember, when we're talking about measuring, it's always positive. And then the other thing that you want to maybe make note of is it's the distance from the midline. And we kind of talked about that already. When you cut the graph in half, it's the same up this way as it is down that way. We're going to cross out the crucial values and we're going to write in midline. The midline is the horizontal line that splits the function in half. So it literally just cuts the graph right in half. Okay? So on your own, what I want you to do now is I want you to fill out the parent graph or chart for the cosine value. So y equals the cosine of x. So now take your unit circle and you're looking for all of the x values all the way around the cosine function. Okay, so hopefully you filled that out correctly. Notice the little bit of difference between the sine and the cosine wave. We're using a lot of the same numbers. So again, square root 3 over 2 is approximately 0.87. 0.7, and this is approximately 0.71. So when we go to graph it, we know they're still under 1. But now when we go down here and graph, again, do your best to make it look pretty and make sure we see the curvature of everything. But I'm just going to do a quick sketch, but you go ahead and take your time, and you should see the curvature that happens. So it's very similar to the sine wave. You can actually see my sine wave behind there because I used marker. But it's really repeating itself over and over again. Still, every 2 pi, it'll start all over again. So my period is still 2 pi. If you take my midline, it's going up 1 or going down 1. So my amplitude or my height is 1. The domain, it keeps going on forever and ever and ever. So we have negative infinity to positive infinity. And by the way, we use parentheses here because infinity doesn't have a definite answer. Where range, we are going to negative 1 and positive 1. So that's why we use the brackets. Okay? So what are some of the similarities that you see between the two? They both start and end 2 pi later. They both go up as high as 1 and as low as 1. They use a lot of the same values. The difference, though, is the quadrants in which they are positive and negative in. And we've talked about that already. If you think about the 4 quadrants, sine and cosine are both positive because x and y are both positive. But when we move to quadrant 2, my cosine now is negative, but my sine stays positive. In quadrant 3, both cosine and sine are negative, and in quadrant 4, cosine is positive, but sine is negative. And that's why our graphs, part of the reason why they shift and look a little bit different. So next week, we are going to really be looking at how the parent graph, so we're always going to compare it to these graphs we did today, how they change when we add numbers to the function.